Okay, today's lesson is going to be talking about solving non-right triangles. So we've talked about before how solving a triangle means to find all of the missing sides and angles, and we've only done that with right triangles. So far we've used trigonometric functions being sine, cosine, and tangent, and we've used Pythagorean theorem and some other things like knowing that all angles have to add up to equal 180 to be able to solve right triangles. So today we're going to be looking at non-right triangles. And one of the things I want to say just before that we get into our formulas for today, one of the conventions in geometry, we always name angles, using 3 letters, but also using capital letters. So for example, we may have like A, B, and C here. And in our formulas, our sides are going to be corresponding to that, and our corresponding sides end up being across from the angles, and they use small letters. So for example, if I have angle A down here, then the side opposite that is A with a lowercase a. Similarly, B, side B is going to be down here at the bottom because it's across from angle B, and it's going to be using a lowercase letter. And the same for side C is going to be on this other side. So just be aware, anything with a capital letter today is going to be an angle. Anything with a lowercase letter is going to be the opposite corresponding side. So you may need to write that down in some way for yourself before you move on. Okay, so the first formula we're going to learn today is a pretty simple one. It's called the law of sines. And all it does is it helps us relate when we know a pair of corresponding things. So for example, this is a set of ratios, and aren't necessarily going to set it up as in terms of 3 congruent fractions. You'll probably just have 2. But notice here it says the sine of angle A related to its side A is equal to the sine of B related to its side B. So to be able to use this, you must have one pair of corresponding information. That's the only way I know to say that. So for instance, you would at least need to know like side C and angle C, or side A and angle A, right? You can't have like side C and angle A and angle B because none of those correspond, which means you wouldn't be able to set up any of the ratios. So let's look at an example of how you work one of these problems. Okay, so in this problem, notice they're asking me to find all of the missing things, so angle T, and then side T and side S. So this is a problem that I could use for law of sines, and one of the things you can think is sines, S is simple. The one we're going to learn in a minute is going to be law of cosines, C is complicated. So law of sines is simple. The reason I can use this one is because I have a pair of corresponding things that I know information about. So this is really easy. I'm just going to set up my ratios. So I know sine of 35 over the corresponding side value, which is 15, is equal to, and now you can pick, we can solve for, well, we can't solve for T because if I pair T together, that's 2 variables because I don't know the angle or the side measure. So it looks like I'm going to have to solve for S first. So that means that's going to equal sine of 38 over my unknown side S. And now this is a lot like when we had to solve before. We're just going to cross multiply until we get S by itself. All right, so the first thing I'm going to do is cross multiply there, and then I need to get S by itself. So I'm going to divide by sine 35. And one of the things I'm going to show you in a minute is where your book kind of warned you about rounding error. I try to work all of this out so that I can just type one thing into my calculator in the very end. So if you go ahead and type that into your calculator, making sure that you are in degree mode, you should get that the side S equals 16 point, says round to the nearest tenth, so that's 16.1. And notice that should make sense that this last side is 16.1 because the angle S is slightly larger than the angle R, so that side should be slightly larger than the other side. All right, and then we can just continue to do law of sines to be able to find T and S. T. Now, I said this just a minute ago, we actually do know the measure of angle T, or we could figure that out, because we know, even though this isn't a right triangle, that all the angles have to add to equal 180. So if I use that fact, I know that this measure of angle T is 107 degrees, and now I can still set up another ratio to solve for the side T. Remember, you can't do Pythagorean theorem here because this is not a right triangle, so you are going to have to continue to use law of sines or cosines. So in this case, one of the other things I'm going to recommend to you here, in addition to not rounding until the very end, is that you use the given information to start every time. That way, if you make a mistake, you're not compounding that mistake over and over again. So I'm still going to start with my sine 35 equals 15, and then I'm going to do sine of 107, sorry, not equals 15, but over 15 over t. And notice that these two problems are set up in the same way. So the only thing that's changed is that now I have sine of 107 instead of sine of 38. And using that, I can kind of shortcut and know that t is going to equal this same setup, 15 times, this time I know it's the sine of 107 instead of 38, over sine of 35. So notice I'm looking at what I have in the box here, and just matching that same setup, because it's set up the same other than the fact that the measure of angle 38 has now become the measure of angle 37. All right, and when I did that this time, I got that t, let me get my marker back, t is going to be 25, and my calculator is giving me 25.00, so 25 is going to be the length for that last side. All right, so this is how law of sines work. Should be kind of pretty simple as far as the setup goes. So let's look at what law of cosines looks like. Okay, so law of sines was good when we had corresponding set of information. Law of cosines is going to be good when we do not have corresponding sets. And unfortunately, when you do not have a corresponding pair, that's going to make what you're doing a little bit more complicated. So that's why I think that cosines is the complicated one. So let me explain to you kind of how this formula is set up. All right, so let me show you what this looks like. I'm going to focus really on this last formula, even though they're all the same in reality. So notice some things about this last formula. The first thing I want you to notice is that this is very similar to the Pythagorean theorem. A squared plus b squared equals c squared. All right, the difference is it's like saying that the Pythagorean theorem has some error because this is not a right triangle. So we've got to add in this other little piece. And this is to solve for a missing side that you don't know. Okay, so that means we know all of this other information. For instance, we know A. This says that we also know B. And it says that I know the capital letter C, which is this angle C in the middle. So notice that what I've highlighted there, I don't have any corresponding pairs, right? Like I know side A, but I don't know angle A. I know side B, but I don't know angle B. I know angle C, but I don't know side C. All right, so when you don't have anything that matches, this is a case for law of cosines. And this formula, it gets a little bit easier to remember, but basically you set up Pythagorean theorem, and then you subtract 2 times the two sides that you know times the cosine of the angle that you know. So let's look at one of those examples together. Okay, so I'm going to take just a second to make sense of the information that I know. So I know this side, which is the lowercase c, that's 5. I know this other side, which is my lowercase a, that's 7. And I know my angle b. All right, that means the side that I'm trying to find is angle B. So I know that means B squared equals, think about Pythagorean theorem, we're just going to set it up. B squared equals A squared plus C squared. I almost wish they didn't give you letters just so that didn't look as strange. We start with Pythagorean theorem, and then we're going to subtract 2 times the two side lengths that I know, which are A and C, times the cosine of the angle that I know, which is 100. So notice that this side length that you're trying to find and the angle across from it should like bookend your entire equation. And everything else in your equation should be values that you've been given. So once you have that set up, you can go ahead and solve. So this is going to give you, plug in values. So I've got b squared equals, where did I say a was 7? 7 squared plus 5 squared minus 2 times 7 times 5 cosine of 100. And lucky for you, we have these beautiful calculators, and you can type all of that in at one time. And I got b squared equals 86 point, let's see, I'm gonna keep a few, it says in the directions, intermediate results round to 3 decimal places. So I'm gonna hold on to 3 of those. That's 155. All right, and then I need to take the square root to get b by itself, just like you do at the end of Pythagorean theorem. So this is b squared, well, sorry, not b squared. B is going to be approximately 9 point, they want me to give my final answer in 1 decimal place, so to the 10th, so that's going to give me 9.3. That's the length of this third side over here. And now if we were going to solve out this right triangle, the only thing we have left to do is find angles A and C. And one of the beautiful things about knowing law of sines and cosines is that now that I know that this side is 9.3, I can use that again because now I have a set of corresponding sides. let me highlight that for you. I've got a set of corresponding sides here in the side angle B and side B. And now that I have corresponding sides, I can just go back and use law of sines, the simple one, because that's going to make it, that's just a lot easier than doing that whole law of cosines that I just did. So if I do that, I can set up sine of 100 over 9.3, or if I don't want to deal with rounding error, I can write 9.282. That's me not rounding in my calculator, equals, and now you get to pick. Do you want to find angle A, angle C? Up to you. So if I find angle A, I'm going to say sine of angle A over 7. And then, just like we've done before, you can cross multiply. Similarly, you could set this up for angle C. You could say sine of 100 over 9.282 equals sine of C over 5. And you would cross multiply and use the inverse. So what I would like for you to do is just to practice with your calculator, if you'll go ahead and work out these two problems just to make sure that you understand what you're doing there. And we'll start tomorrow setting up a few of these together so that you start to feel better about how to set up and to use law of sines and cosines to solve non-right triangles.